Welcome to Beyond Chips, the Chips GU podcast, where we explore people, projects, and partnerships shaping Europe's semiconductor future. I'm Luciano Gaudio, Head of Communication at Chips Joint Undertaking.
And I'm Vasily Peglidou from the Communications team. Together, we'll be your hosts as we speak with researchers, innovators, and industry leaders behind the technologies powering Europe's digital and green transition.
In every episode, we'll go behind the scene of Chips GU founded projects. We'll hear stories of collaboration, innovation, and real-world impact, from lab to the fab and practical application.
Whether you're part of the Chips GU community or just curious about how semiconductors are quietly transforming everything around us, from farming to mobility, you're in the right place.
Our conversations are guided by a shared principle: clear, respectful, and inclusive communication, just like how we work every day here at the Chips Joint Undertaking.
So let's get started and meet the people behind Europe's chip-powered future. Welcome back to Beyond Chips. In this episode, we explore HiEFFICIENT, a Chips GU-funded project focused on developing more efficient and reliable electric drivetrains through next-generation power electronics. As electric mobility continues to expand across Europe and globally, improving energy efficiency, reliability, and system integration, it has become increasingly important. Christoph, electric mobility and semiconductor technologies evolve extremely quickly. What keeps you motivated to continue working in such a fast-moving sector?
Yeah, thanks for inviting me today to this podcast and having a chance to give some insights into HiEFFICIENT project. And when you're asking me what keeps me motivated, is that I've actually seen the technology moving from lab curiosity at the beginning when I started to something like powering millions of cars. Yeah, and when I started in back, it was almost 10 years ago, starting with my first project with the Chips Joint Undertaking. Wide bandgap semiconductors like Silicon Carbide and Gallium Nitride were like considered exotic. Yeah, it's like that a little bit. And in 2018, then Tesla brought first electric vehicle Silicon Carbide technology to the market. Yeah, and that was when I started with these technologies, doing research and developing new devices with my partners. And today it's like most of the OEMs are adopting this technology, bringing it to the market, and it's widely used already. Yeah, and besides Silicon Carbide, there's also Gallium Nitride, as I mentioned already. And this is not so broadly used now in automotive industry up to date, but it's broadly used in consumer electronics already. Yeah? You may know your mobile chargers, they are getting smaller and smaller. And here, Gallium Nitride is really adopted, I would say. But this bears a huge potential also for the automotive industry, which is not there yet. And that's, I think, really exciting, or it's an exciting transformation, which is still ongoing using these technologies. And there's still a huge potential for transforming improvements. And yeah, being part of that journey, it's really keeping my curiosity and also seeing this directly impact to real products then at the end.
Christoph, for listeners who may not be familiar with power electronics, what is a HiEFFICIENT project trying to achieve in very simple terms?
Yeah, so it's basically the power electronics are at the heart of each electric vehicle. Yeah, it's so to say the translator within the vehicle, transforming AC and DC energy as you need it. Yeah, basically when you're charging a vehicle, you're getting AC power from the grid. You need DC power for the battery, so you need to transform it. That's the first step. And then when you're driving your motor, you need again AC. So it's again DC from the battery towards AC in the motor. So that needs energy conversion at the end. That's what the power electronics are doing. And the bad thing is when you're transforming energy, you're losing some of them. And that's what you want to optimize and to improve, to really minimize losses at the end. Yeah, and losses, it's like money. So when you're charging your battery and you're losing energy towards the wheels, then it's not everything moving you forward. It's also losing money at the end. And that's what keeps us curious about getting efficiency as close as possible to 100%, even if this is not really reachable. But every percent counts, I would say. Having longer driving ranges, lower cost for the end user, and at the end also more sustainable because you don't need so much energy for driving at the end. Yeah.
Speaking of energy and percentages, HiEFFICIENT is aimed for efficiency levels above 98%. So why does even a small percentage improvement matter so much in electric mobility?
Yeah, I mentioned it a bit already, but as I said, every percent counts more or less, and to bring you forward with the vehicle. So when you're losing energy, basically it's just generating heat, which you need then to cool additionally. So things getting complex, you cannot make it that small at the end, which is also then reducing room within the vehicle. And the cost of a lifetime also increase then for the user. So every small percentage is nice for the end user, nice for the environment. And that's why I think each percent counts at the end then for the user as well as the environment and at the end. Yeah.
Christoph, people worried about EV battery life, but your project focus on the electronics life indeed, amongst other things. So why is that a 20% increase in reliability so critical for consumer, according to you?
In my eyes, there are two main reasons. Again, it's the cost. And secondly, it's about also future applications. Well, what does this mean? Yeah, first, of course, in case power electronics last longer, the cost of ownership goes down, right? So you can use it simply longer. It's good for the user. It's good for the environment. Secondly, that's, I think, even more important. Cars are getting kind of part of the energy system itself. Yeah, of course, today you are charging the vehicle and you try to get the energy into the vehicle to drive. But you may have heard that it's also about stabilizing the grid. In case you have so much renewables in the network, you need also to balance the grid, and therefore vehicles can be used as a kind of balancing device, using the battery energy, getting it back to the grid in case you need some peak power for the one or other moment. And therefore, the components being in the vehicle need to last longer because they are much more longer in operation. They are not just charging, they are giving back the energy, and then you need to charge it again. So that, there's a factor, maybe 10, whatever, of lifetime, which you will need then at the end for the component. And therefore, it's really key to enhance reliability of the power electronics. We did that in several ways. We looked into different packaging concepts, how to make that more reliable. It's about thermal things, how to cool them more efficiently and reduce the risk of failure. So there are a lot of things ongoing in that direction, and it's really essential to improve reliability at the end.
If we're looking a little bit at the big picture, the project is now finished. So looking back, what is one sort of breakthrough moment that you will remember as a defining success of HiEFFICIENT?
Looking at the project itself, there are more than 30 partners working together, and there are a lot of dependencies at the end that do make the project successful. So each and every partner is part of the supply chain to get from the beginning of the development, like having semiconductor developments at the first step, and then bringing them also to the application. That's a huge effort to do that. And I think the breakthrough moment was like having the chips then in your hands at the first time. Yeah, so really having the basis for doing all the application development. That was, I would say, somewhere in the middle of the project. And so it's like getting things to life, make it real, that it's not just theoretical, that you can do it, but then you are really able to do it at the end. Yeah, and this is, I would say, one of the breakthrough moments. Of course, there are other really significant moments, like having then the final review meeting where you see then all the demonstrators with the integrated chips being showcased. So that's also, I think, was a really nice moment to see what we have really accomplished as a team during the project lifetime. Yeah.
Christoph, let's get a bit into the role of CHIPS joint undertaking. How did CHIPS GU funding help accelerate the development of the technologies explored in HiEFFICIENT? And in the end, what would this work look like without collaborative European funding program?
Yeah, I think it's really a big value to have such opportunities to bring so many partners together. It's really about this collaborative effort to work on, I would say, a headline. Yeah, it's like making electric mobility real by using latest semiconductor devices. And this is really along the value chain. So you need the semiconductors, you need the semiconductor industry, you need suppliers, you need the automotive OEMs. Yeah. And besides that, of course, there are a lot of leading research institutes also involved. Yeah. And having all them together in one team, you won't be able to do that without funding, because setting up such kind of complex consortia, that will not happen in daily life or in daily work, I would say. Of course, you have your collaborations with the one or other partner, but then it ends. Yeah, it's somehow breaking up the silos at the end. Yeah, and enabling at the end and faster innovation. Of course, you can debate about that. Yeah, you have 3 years of project runtime. It could be even quicker or faster, like China's speed, as it is named sometimes today in the automotive industry, where even 3 years are too long. But it really fosters the collaboration between partners. It helps you to keep these collaborations alive. And especially for these early stage technologies, funding is really also crucial to kick it off and to try sometimes also crazy things, yeah, which you would not do without that. Yeah.
Looking a little bit more in the different geographies involved in the industry, how does HiEFFICIENT help Europe compete with the US and Asia in the semiconductor race?
Yeah, thanks for the question. It's, I think, one of these key contributions which HiEFFICIENT was able to demonstrate is this kind of cutting edge GaN technology with really globally competitive performance. Yeah, we had really new concepts regarding system on chip, system in package integration technologies, which were leading edge at that point in time when we delivered them. And this really helps to increase the level of integration, combining power devices and control functionality just in one housing, yeah, and therefore delivering really compact solutions, yeah, which reduces then complexity and size. And since we were really at the edge, compared also to the global competition, be it in US, be it in Asia, it was really the first time to have such devices delivered in that project in general. And I think that helps compete with the companies in US and Asia. But, it's fast moving. You have one thing achieved, but then there are other things upcoming again. So you need to continue in that direction, and it doesn't ever stop at the end. Yeah, but you can try to keep the pace at least. Yeah.
Christoph, now a point of view of an expert, of course, like you. What challenge is still somehow underestimated, say, in power electronics or anyway in the broad sense in the sector of electric mobility?
Well, from project perspective, honestly speaking, it's almost the timeline. You start developing things, you usually don't fail, but you need to go other paths to achieve the results. And all the time, it's really tricky to get the set expectations to life. Yeah, so you start at low technology readiness levels. You often need to change direction, try new approaches. Yeah. So this is, from project perspective, I would say, usually the not underestimated. It's kind of expected challenge. You're also addressing them at the end. And of course, then there are the dependencies between all the different steps. You have advice, you have some thoughts how you want to design things, and all that needs to get together. But I think that can be solved also with strong collaboration and finally delivering decent results, I would say.
I have another question, Christoph. So most of the people, I can safely assume, listening to this podcast will not be in the field of electric mobility, but will probably have had the chance to drive a car in their life. So how has the project changed how you personally view the future of mobility when you're driving your own car, just to make it a little bit more relatable?
Well, it has changed somehow because I just bought recently an electric vehicle, so I switched the technology, so to say. And when I'm sitting in such a car, you're thinking about a little bit, you think differently about when driving it. So you're thinking about the technologies which are in it. And certainly that has also a little bit influenced my decision to go that way. And besides the sustainability effect, which is, I think, well known using an electric vehicle.
Let's put the human factor in the center now. And of course, talent, skills, people motivated is the key to go ahead and secure development and advancement in any sector. So for younger engineers or students listening to this episode, what advice would you give to someone interested in entering these fields?
Well, it's not an easy question. Maybe there are a couple of things I would highlight here. I think, of course, first it's about strong fundamentals. You need the basics, and the thing which is really important is also to stay curious beyond that. It's not just the electronics itself, it's more system understanding, and that's where the real innovation then happens. It's not just the small things, it's the sum of the things, and you need to connect disciplines at the end. Secondly, it's like getting hands-on experience. It's not just the theory, it's really working on it, getting your hands dirty somehow. And when working on real-world problems, you much faster understand it's not just the theory alone, it's really understanding how everything interacts then at the end. Then thirdly, what I already mentioned, it's about collaboration. It's not working in your own room and doing it on your own. It's really interacting with others, because problems are getting much more complex, and they are much too complex for just one individual. And here it's also across disciplines working together. It's, when you're working about power electronics, it's about, of course, how to control it. Then it's how to cool it, how to build it. So there are a lot of factors which need to be considered. And maybe the last one is also what maybe can motivate you. It's really thinking about the bigger purpose, why you're doing it. Of course, the energy transition should help us to stay on the planet and to live on the planet. And I think it's also technically exciting. A lot of things are happening. And at the end, it's also, for me, it's crucial for sustainability to make this transition from the oil-based energy towards the new energy-based industry, I would say. And I think that should also keep young people motivated to work in that field.
Thank you very much, Christoph. The electric mobility is for sure one of the most important sector where future generation needs to enter in a different way of thinking about environment and about mobility, energy saving, and so on. So we really hope that CHIPS joint undertaking may support even stronger this kind of sector. So thank you very much again.
Thank you very much for having me today, and looking forward for the challenges ahead.
Thank you, Christoph, from my side as well, for sharing your views. Thank you.